So good morning everyone. So in yesterday's class we discussed the application development in database. Today we shall discuss a new topic, internet applications. So here we will study how resources are identified on internet, how browser and web servers will communicate with each other, how documents are formatted, how to differentiate between a formatting and a content, how many layers of application uh, can be designed, their architecture, and why application servers are required. So here the concepts that we will be studying will be uniform resource identifiers, HTTP, HTML, XML, JavaScripting, and to some extent we will study the common gateway interfaces and Java server pages. So these are the technologies that we will be focusing on. So yeah, this is the summary of what we will study, the internet concepts. So the internet has emerged as a universal way of globally connecting the distributed software systems. So if two softwares needs to be connected to establish a communication, we need the presence of internet. So in order to understand how it works, we have to discuss two things: how a website on the internet are identified, and how program at one website can communicate with another site. For that particular purpose, we will be using the uniform resource identifiers. So uniform resource identifiers are a string that uniquely identify a resource on the internet. A resource can be anything. A resource can be a web page itself or a part of a web page. It can be audio, video, image, anything that is present on a web page. So the example of a sample URIs include this. For example, HTTP colon slash followed by the address of that server, or we call it as a domain, www.cs.wisc.edu.slash. This is the path within this server. At this folder, this particular index.html file will be present. And on the internet, you can observe this particular path on the browser URL, or if we are using a mail server, so we can use mail to colon webmaster at bookstore.com. So these are the few URI. So if you observe, it is the I, it is not URL. So L means the locator, I means the identifier. So locator usually we will use for a web page, entire page itself, and identifier we can use for a page and the resources or the contents that is present within that page. So if in a web page we have a 10 images, so each one image can be identified uniquely. So the path to identify each image, we call it as uniform resource identifier, and the entire web page we call it as a uniform resource locator, URL. So structure of URI. So there is a structure for uniform resource identifier. So it has three parts. So first is the name of the protocol that we use to access the resource. So that we also call it as a naming schema or the protocol, that is HTTP. So in this particular case, it was HTTP. Then the host computer where the resource is located, or name of the host computer. So in this case, it is present in www.cs.wic.edu. So here we are just giving a name. So finally, when we access this particular host, this name will be converted into an IP address. So that conversion will take place at a domain name server. Once it is converted, it will be mapped to a particular device. So which means we are accessing a particular device, but in order to give a, a name, so that every time we can't type the IP address or the numbers. So a domain name has been given. So just like how we store mobile numbers under contact names. So each time when we want to dial or send a message, so we will use the contact name and we will not type the number, because it is hard for us to remember everyone's number. So for each number, we will be giving a name. So just like that, for each host computer, a name will be given. That name we call it as a domain name. So the third part is the path to the resource, or the name of the resource. So it is also called as a path to the resource. So this is the path, dbbook/index. So that is the path within the host computer where the resource is present. So that becomes the name of the resource or path name. So URLs are a subset of URI. So which means all URLs are URIs itself. So this is the URI. The next concept under internet application is the HTTP, that is Hypertext Transfer Protocol. So this Hypertext Transfer Protocol, it is a communication protocol which is a set of standards that define the structure of messages between two communicating entities so that they can be understood by each other. So a protocol means it is a set of rules for message format. That's it. So if a message is sent in a particular format, then the receiver will understand what is the meaning of it. So the example protocols over internet include the TCP, IP, and HTTP. So TCP stands for uh, transport communication protocol, then internet protocol, HTTP, hypertext transfer protocol. So what happens when we click a particular link? So when we click this particular link, so what happens is the request is sent to the domain name server to identify the host computer details. So once it host computer details is known, HTTP request messages will be generated. So a request message, a client browser will send it to HTTP request to the server when we click on this particular link. So the server receives the request and it will reply. When a client receives a reply, the client can make new requests. So these are some of the message formats in HTTP, how the communication take place. So client send this particular information. So get index.html http/1.1. So user agent is usually the browser information along with the request is also sent. And then the data that is being passed in the request was also sent. So this is general structure of HTTP request. So it may contain several lines of ASCII text with an empty line at the end. So the first line, that is the request line, has three fields. So the HTTP method that it will be used, the URI field, and the version of HTTP. So the first get is a keyword. It is the method. So there are two methods, that is get method and post method. So get request can be sent using get keyword, then followed by the URL and the version of the HTTP. So the version field indicates which version of HTTP is used by the client, and it can be used for extension purpose or upgradation of the protocol. The user agent indicates the type of the client, whether it is a Mozilla or a Chrome or Internet Explorer. So that will be indicated. The third line is the uh, starting line with accept keyword, which indicates what types of files the client is willing to accept. For example, if page index.html contains a movie file with an extension .mp4, then the server will not send this file to the client because in the list we have not mentioned the .mp4. So the only list which we have mentioned over here, those files will be sent by the server. And response on the other side, so this is the HTTP response. It retrieves the page html.index. Then it uses it to assemble the HTTP response message and sends the message to the client. And the reply will look like something like this. So here the response message contains three parts: status line, a header lines, and the body of the message. So body of the message is the actual object that the client has requested, and the status line field indicate whether it is a server message is okay, or there are any error codes, HTTP version, so all those things will be there. So HTTP/1.1 is again the version. 200, it is okay. These are the keywords. It indicates the request is successful and the object is contained in the body of the response message. If this number is 400, then it indicates it is a bad request. Bad request is a generic error code indicating that the request couldn't be fulfilled by the server. And other error codes include 404, 505. So 404, majority of the times you might have seen it. So it indicates it is not found, resource not found. 505, it is the error related to HTTP version not supporting. So those things will be present in the first line. So then it will be having the header lines. So first header line contains the date. So date and time when the HTTP response was created. So along with that, the last modified header line indicate when the object was created. The content length header indicate the number of bytes in the object that is being sent. So the content type header line indicates the object in the entity body. So when a client receives this particular message, so it will start extracting only from this HTML. So whatever there is in angular brackets, so we call it as tags. From here it will start extracting, and that process we call it as parsing. So it will extract and display this particular web page. So this is the protocol structure which we already have in the screenshot. So the other information that can be sent in a response include the server type, server time, and so on. Okay. So there are few issues regarding HTTP protocol. First, it is a stateless protocol. So which means stateless means it doesn't maintain the state. So every message that is sent from a client or received at a client, so it is a new one and it has to be maintained only and until that the message is sent. And no previous information will be remembered this by protocol. So that's why when many of the pages, when we press the reload button, it will ask us for a confirmation whether we want to resend the information. So that is due to this stateless nature of the HTTP. So it doesn't maintain the state. So the implication for application is, so any state information, that is for example the user login or the shopping carts, need to be encoded in every HTTP request and response. So the popular method of maintaining a state includes cookies or dynamically generated unique URL at the server level. So if HTTP doesn't remember anything, then the application should search for alternate ways where it can remember the things. So one such way is a cookie. So cookie is nothing but a small information that is stored in the client browser. So you might have observed it when you visit certain website. At the end, there will be a declaration and it will ask you to accept the cookies from that site. Or the dynamic URLs can be generated to maintain the information about the application. So HTML documents will have a format along with XML, DTD, and XSLT. So we shall study these four concepts. So these are the data formats. So this is a normal text file which we type in Notepad. It will be similar to that, but within that there will be some markings in the angular brackets, what we call it as a tags. So how the tag structure varies and the purpose for which those files are used, depending on that, these are the four different types that we will be using. Since they use a tag concept, so a tag is called as a markup. Since they follow the tags, they are also called as a markup languages. So HTML, XML, DTD, and XSLT. So all these four are the markup languages. So this is an example HTML file. So those who have studied CS in their 12th may be aware of this. So this is the web page. So everything is placed inside this particular tag. So starting tag is HTML, ending tag is HTML. Then head indicates it is the header tag. So body indicates the content. Within that we have H1 tag. So H1, H2, H3, H4, H5 and H6. So they are related to the size, font size. Then B indicates bold, UL indicates the bulleting unordered list, LI means list elements. So this is a sample page. So you can just copy the same as it is and paste it in a notepad and open it in a browser. So you can observe how this particular content will be visible for us. So in short, HTML is a markup language. So here the commands are called as tag. There will be a starting tag and ending tag. So you can observe over here, ending tag is indicated by this forward slash. We have many editors which automatically generate the HTML file directly from our document. So all web page what we saw on a browser, from our Facebook account to Hotstar, Woot, Netflix, everything is built on HTML only. So these are the sample commands. So each tag has its own functionality. For example, UL indicates it is an unordered list. So whatever you are seeing here, that square boxes. So this is the unordered listing. So and its nature is it is in square box. So on this slide also we have the unordered listing. So this kind of bullets comes under the UL, and each element of this bullet is entered in LI tag, that is list entry tag. So H1, H2 are the heading tags. So again the font sizes will vary. So this is the sample XML file. So XML stands for extensible markup language. So this is a document format, and it can be utilized by the applications for several purposes. So here you can observe. So in most of the applications, this XML is used for the configuration purpose, and it can also be used as a lightweight, very small database also. So in the normal text file, so you can observe here book list. At the end we have a book list. So this particular XML file is holding the list of books, and each one is a book. Book contains author, title, and published year. So that is a first book. Second book, and it is having a attribute that is genre is science, and the format is hardcover. So like that, each information we can store over here. Just like how we store the data in the database, so it will get stored in a table format, right? So the table format, each attribute is preceded with a tag, and the entire tuple it is encoded in a another tag. So that forms the uh, XML. So you can observe over here, that is book list starting here ending here, and book, first book, it is still here. So this is the first book, then this is the second book, then this is the third book. So each book is having author, their information, title, published. So like that, author, title, published. So these things are present. So the same which we store in table format, so we will be uh, storing them inside the tags. So that format or file we call it as the XML. So XML, to brief, it is its full form is extensible markup language, and it is developed as a remedy to overcome the shortcomings of HTML. So in HTML, all the tags which we use are predefined and standard. We cannot use our own tag names, but in XML we can use our own tags. So it is a way of communicating the information. So it is also follows the markup language syntax. We can store the names or metadata or data itself in the XML. So it is called as extensible because there is no limit. It has a limitless ability to define new language or data set. So we can also include data and description of what the data represents. So it is called as a metadata. For example, a chemical markup language can be written like that: molecule, its weight, its spectra, figures, and the molecule. So like that, we can define our own language based on our the application. So XML is designed to make it compatible with SGML. So SGML stands for Standard Generalized Markup Language. So it is a meta language that allows the definition of data and the document interchange languages such as HTML. And it should be easy to write and process the XML files. So the design should be formal and precise, because any XML file, if we open and look at it with our eyes, we should be able to understand it. At the same time, the machines should also understand it. So both human and machine readable formats was the main reason why XML was introduced. So XML, it is a amalgamation of SGML and HTML. XML looks like HTML. XML follows the hierarchy of user-defined tags with attributes and data. See, whatever inside the tag we write, that is gener is equal to science and format is equal to attribute. This gener and format, so they are called as attribute, and whatever we write in the double quotes or single quote, it is the attribute value. And this attribute and the database attribute which we discuss or which we have studied are completely different. So opening tag, attribute, attribute value, then in between opening and closing tag, we will have the data, and then finally the closing tag. And remember, the data can also be a tag itself. And any level of nesting is allowed in data. So XMLs, the other properties include it is case sensitive and space sensitive. Uh, every opening and closing tag name must be same. Opening tag will appear like this and closing tag will appear with the forward slash. So empty elements have no data. If data is not present, then the same opening tag can be used for closing tag also, but this time the forward slash will be used at the end. So book like this. So this indicates the data is not present and it is completely empty. So instead of writing a separate closing tag, the same one can be utilized by writing a forward slash in the opening tag itself. So attributes. So this attribute in XML tag provides additional information for element tag. So there can be 0 or more number of attributes in every element, but the format is, it should be attribute name is equal to, within the quotes, attribute value should be mentioned, and there should be no space between the name and the is equal to symbol. Multiple attributes are separated by spaces. So if we are writing two attributes, then from one attribute to the second attribute, there should be a space. So XML data is any information between an opening and a closing tag. XML data must not contain the symbols. With inside the data, we cannot use these two symbols, angular brackets, because these angular brackets denote the uh, opening and closing of a tag. If at all we want to use them, then they has to be present inside a quote. Comments can be written like this. So angular bracket, exclamatory mark, followed by a hyphen. then comment, and comment should be closed with this. So in some formats, two hyphens will be used, both at the starting and ending. So XML tags can be nested in a tree hierarchy. So XML documents can have only one root tag. Then between an opening and closing tag, we can write any number of data elements and the combination of data and element. So you can observe here, root element means the first and the last. That should be same. Then tag 1, we can write a text, and inside that we can put one more tag. So which means the data field of one tag may contain another data or a tag. So storage, XML is stored just like a tree format. So like this over here, the same thing is represented. So everything is a tree. So the root element is the root tag. Within that we will have tag 1, then some text. Within that tag 2, then more. So the same tag structure is mapped into the tree structure. So element, name of the element and its value. So it is a root, tag 1, tag 2, then value is more. Here on the other side, it is some text. So like this, the uh, XML data, whenever we are loading in the application and parsing, it will be in the form of a tree. And that particular tree structure, we call it as a DOM. So DOM stands for Document Object Module. So that is the DOM. So the tree structure of any markup language can be represented in a DOM. So next we have DTD. So DTD stands for Document Type Definition. So this DTD acts as a schema for XML data. So XML file we can write, but in order to process that file, we need a DTD, and DTD will tell us with the set of rules which specifies what elements are used, what are the attributes, and what are the entities. So all those things will be mentioned in the DTD. So it acts just like a metadata. So DTD specifies which elements we can use and constraint on these elements. For example, how elements can be nested, where elements can appear in the document. So a validity of a document can be established based on the DTD. So if we are storing all the book information, there should be structure for that particular uh, XML file which is storing the book. Some application, if it wants to validate that particular XML file, book XML file, it needs to know what are the attributes and element possible in a book. So that all possibilities will be specified in the DTD. So DTD says what elements and attributes are required and which attributes and elements are optional. So it is just like the structure of a XML file. So the structure of a XML file and all the constraints will be specified in the DTD. And whenever we process an XML file in the any application, DTD will be referred and the conformance will be established, whether all the rules that is specified in the DTD is followed or not. So this is an example of a DTD file. So DTD will look like this: XML version 1.0, not equal to element basket, then uh, followed by the type of the attribute, that is cherry, apple or orange, star. So this Plus indicate it should be present at least once. A star indicates it is optional, 0 or any number of times. That particular tag can be present. Within that, we need to define what it is. Element cherry is empty. Empty means it doesn't contain data. Attribute list, flavor, it may contain attribute. That is, attribute is flavor. C data means character data. Hash required means compulsory. So which means whenever a cherry tag is specified, it must compulsorily contain an attribute called as a flavor. Again, element apple empty. Empty means it doesn't contain any data, but it may contain attribute. Then attribute list. List of possible attributes in the apple tag can be specified using att list. So att list apple color, which means color can appear as an attribute. So you can observe over here. C data means character data. Hash required. Required means compulsory field. So whenever an apple tag is specified, compulsorily we must specify the color attribute. So if color attribute is not written, then obviously we are violating the DTD norms. So like this, we can specify the elements, what elements can appear. For each element, what attributes can appear, whether they are compulsory or not. So all those things can be specified in DTD file like this. So this is a simple DTD file specifying the basket. So on the other side, you can observe here the apple is there, but attribute is not present. So if I whereas color attribute is the compulsory field in the apple element. So it is, we have written hashtag. So the second example, whatever we have written over here. So this is violating the DTD. So because, so here the apple is not containing the color attribute, and here orange also it is not containing the attribute, but in orange hash required is not written. So which means it is optional. So this is valid. For cherry, flavor is there, flavor attribute is there. But for apple, color attribute is not there. So this entire second one is a invalid XML. This one is optional. So every basket element must compulsorily contain one cherry. Then if apple is written, then color should be there compulsorily and no data is present. And orange, if it is present, then for that location can be specified, whereas this location is not mandatory field. So like that. And if you observe here, if the elements are at the same level, then its order doesn't matter. So we can write the apple first, then we can write the cherry, like that. So ordering doesn't matter because it is a tree structure, and in a tree, if elements are at the same level, then their order doesn't matter. So an element will be declared in this particular format. Name of the element. So the tag name is element preceded with this exclamatory mark. So that indicates the declaration of an element. And what childrens it can have can also be specified. That is cherry, apple and orange. They are the childrens. So content type we can specify. It includes the PC data, which means parsed character data. Then empty, which means no content. Any means no checking of inside structure can be done, or we can write a regular expression just like how we have mentioned plus and star. So a regular expression has the following structure. So we can write the expression like this, a list of regular expression. So star indicates it is optional with 0 or more occurrences. So plus indicates an optional expression with 1 or more occurrences. So, and we can connect many expressions using this slash symbol or pipe symbol. So just like that attribute, there is a syntax. So att list, element, which element it is, name of the attribute, type of the data, and it is a flag. So att list defines the list of attributes for an element. So attributes can be different types and they can be made mandatory or optional, and they can also have a default values. So if default values are there, so they can be specified in the flag. So, and there are two types of data, that is C data and PC data, that includes character data and parsable character data. Okay. So here it is a example of well formed and well formed but invalid data. So you have already seen an example of, if it is valid, we call it as a well formed and valid. Otherwise, it is an invalid file. So, yeah. So we can stop our discussion till here. So we can continue with DTD in our next class. So you can enter your attendance in the chat.